Protein half-life is the time it takes for half to be removed by protein degradation. Let me draw this graph. So we have time here and protein concentration. And let's say this is T and we have Y protein. Let's say initially we have 10 micromolar. Then here we have 5 TH. The protein half-life in this case is this. So TH is basically half-life. Again, it's the time it takes for half to be removed. So this half is removed by protein degradation. The half-life of RFC1 protein is 9 hours. And let us assume that this protein is Y protein, and we can have a discrete time difference equation. So Y of I is equal to perimeter, degradation perimeter Py times Y I minus 1. And the time interval is 1 minute, which means that this 9 hours is equal to 540 minutes. Let's start from Y of 0. And how about Y of 1? This is Py, which we don't know, times Y of 0. How about Y of 2? This is Py times Y of 1, which is this value, right? So this becomes Py times Y of 0, which is equal to Py squared Y of 0. And if you keep doing this, you will find this pattern. Y of n is P sub Y to the power of n times Y of 0. Now we have this equation, Y of n is equal to Py to the power of n times Y of 0. Let us define this h as the half-life index. What we mean by this is this. So Y of h is P sub Y to the power of h from this expression times Y of 0. And we say that value is actually equal to 1/2 of initial Y value. Y of 0 cancel out. So we have Py to the power of h is equal to 1/2, which is 2 to the power of -1. Now, this can be expressed as log base 2 Py to the power of h is equal to log base 2 to the power of -1, which is -1 times log base 2, which is -1. This equation also can be written as h times log 2 Py is -1, and log base 2 Py is equal to minus 1 over h. And finally, Py is 2 to the power of -1 over 8. Previously, we mentioned that RFC1 protein half-life is 9 hours or 540 minutes because our time interval is 1 minute. This value is h. Our P sub Y is equal to 2 to the power of -1 over 540, which is 0.99872. So this is how we can come up with this degradation parameter value given the half-life of protein. Okay, this is what we have so far. So P sub Y is equal to 2 to the power of -1 over h. And when time interval is 1 minute and the protein half-life is 540 minutes, then this degradation parameter P sub Y becomes 0.99872. Now let me draw a graph that shows the relationship between h and P sub Y. We know that h is an integer and it is greater than 0. First, when h is 1, P sub Y becomes 2 to the power of -1 over h, which is equal to 1/2. When h is 1, we have 1/2 here. We get this point. How about when h is infinity? Then this Py value becomes 2 to the power of 1 over infinity, which is 2 to the power of 0. because 1 over infinity is basically 0, which becomes 1. So if h becomes very large, then we approach this value 1 for p sub y. So we start from 1, and it will be something like this. We have some value for 2, some value for 3. As h increases, we will approach 1 for p sub y. So this is the plot basically we get for this h value, 540. So if you keep going on in this direction, somewhere we have this 540, right? And that value will correspond to 0.99872. Now, what if our time interval 1 hour? Then this RFC1 half-life is 9 hours. Then what will be this p sub y value in this case? So let me just calculate that value, p sub y, which is equal to 2 to the power of 1 over h. But in this case, now we have 2 to the power of 1 over 9, right? Instead of 540. And this value is 0.92587. So if we are somewhere here, then your value becomes 0.92587. So we see that your p sub y value depends on the time interval.